Welcome to the course on Dam and Network Safety by International Commission on Irrigation and Drainage and Aqua Foundation, an initiative taken by the organizations jointly for promoting the scientific and systematic manner in which the dam safety has to progress in the country and in the world. Welcome to the lecture on an overview on dam and network safety. This lecture is attempting to provide you with an overview covering all aspects of dam safety that you are likely to encounter during your course of work in the dam safety assurance area. This work is very important because at the departmental level, it is the role of the owner to really look at and carry out the activities and coordinate those activities in a manner that the desired results are achieved. Other experts, other areas people, they keep coming, they provide their own inputs, but then the holistic view is to be taken at the departmental level. So from this angle, it is very important that the dam safety managers have a holistic view of the dam and network safety, and this course is attempting to give you that view and give you those skills. Well, now let us look at the overall importance of dams and the role they play in providing us with the water, food and energy security. Dams form the lifeline of water and energy security in a monsoon-based country like India and many other parts of the world. If you do not have storages, it is not possible to manage the water which is available for a very short period of time in a year, and you have a whole year during which you would like to consume that water. So the dams form the lifeline of water and energy security and food security as well. With the growth in economies and with the growth in the food demands, the population of dams across the world has been increasing. India is no exception. Rather, it has done reasonably well. India has put in 5,254 completed large dams as per the ICOL definition, and 467 of such dams are under construction. There are innumerable dams of smaller height which are not enumerated so far in a systematic manner, even though the information is available at the organization level about their parameters, but they are not being put in any register. Substantial portion of our large dams have aged more than 50 years. Their initiation of their construction took place in the early phases of 1950s, and we had a very active period of dam building till about 1980s. And now a substantial number of dams have become old in the sense of time, because almost 50 years have passed, but their importance have grown manifold. The importance of dams actually increases with time, because once we get accustomed to a sustained availability of water, we plan our economies, we plan our securities on the basis of that availability of water. And then even a small disruption in that availability of water becomes very painful for the society. So it is increasingly important to maintain the dam in a safe and sound manner, so that it is possible for the dam to provide you with the benefits that you are expecting from this project. With the change in hazard profiles, the hazard profiles keep on changing over the time because of various reasons. There are economic reasons, because once the dam is in position, the downstream channels become more amenable to other human activities. There are encroachments which increase with the time. There are other issues which come up, like that of the change in the hydrologic parameters, or change in the seismological parameters, or the deterioration of materials, and with that the hazard profile of the dam keeps on changing with the time. And we need to ensure that the hazard at which with which the dam is posing to the downstream public remains the same, or remains at the acceptable level, with which the people are able to enjoy the benefits without getting worried, or without getting worried about the losses that may really come their way in the event of any malfunction in the dam, or in the event of any breach in the dam. So these issues are something which we need to really look at very systematically when we have to set up a dam safety management program. There are standards involved here, there are material sciences involved here, there are natural sciences involved here in form of hydrology, seismology, geology, etc., and many other areas which are involved here. So let us now start looking at all those areas in a systematic manner. So the next important question is that what is dam safety management? The dam safety management, as we said earlier, is that the dam safety management has to ensure that the dam continues to perform its intended function with acceptable hazard to the public living downstream. The value or the term acceptable hazard is a very important term, because any man-made structure, when you create on the face of earth, it poses a hazard to the people who are consuming it. For example, even a building that you create, that will also create a hazard to the people who are living in that building in the event of a major earthquake taking place, or in the event of any flooding taking place, or some other such phenomena taking place. But still, people accept living in those homes because it otherwise provides them with a continued shelter and security and life, which otherwise they would not have been able to get had they not been able to move into those buildings. So each engineering structure poses a hazard, but then the hazard has to be acceptable. We know that such an hazard exists, but then we make sufficient preparations, we make sufficient thinking and plans, so that as and when that kind of hazard occurs, we have sufficient time to manage the safety of lives, manage the safety or the limited damage to the properties, and we should be able to again get back to the life once that particular hazard has passed. So this acceptable hazard is the key word for the dam safety management, that how much you keep your dam safe, to what extent you will go. Would you completely replace the dam, or would you be able to repair the dam, or would you be able to continue with the present position? These are the questions which are all based on the acceptable hazard thinking. Now, when you have to ensure the dam safety, surveillance is the key. If you have to look at the status of the dam from time to time, and once you look at the status of the dam from time to time, you will realize that there are certain changes occurring in the body of the dam, in the surroundings of the dam. And what are those shortcomings? Are they due to aging, or lack of maintenance, or changes in the risk levels due to climatic, seismological, material, or developmental parameters? Once we determine that what are the new areas that are of concern that has come up, then we have to employ technologies to understand the phenomena. What is its ultimate impact? What are the timelines against which these phenomena will become unbearable? And then how to really remedy these deficiencies that have come our way. And then prioritize those works, because when you have a large portfolio of dams, as we have seen earlier, you will need to really look at what is more urgent, and for that you need to do quantification of that urgency, so that you are able to rank the works and then take up the works and finances based on that priorities. So once you have prioritized, then you have to carry out the remedial works which will ensure the acceptable hazard level to the public, and then we again continue our surveillance, because dams are like diamonds, they are forever. We cannot see in a water short country like India or many other parts of the world. You cannot foresee a day when this dam will have to be removed. Even where the dams are being removed, they are being substituted with other dams or other similar structure in order to maintain the water supply. So this is a never ending process. Every regular interval we have to keep on checking on the health of the dam, we have to keep on improving, and we have to keep on carrying out the maintenance or management in the manner that is suitable for making the dam safe. Dam safety has been propagated primarily with the concept of dam failures. I personally feel that dam failures were the ones which acted as a trigger for looking at the dam safety as a discipline. Dam failures are always very, very catastrophic. They lead to large loss of lives and very large loss of economic properties and economic values in the society. Failure is characterized as failure which leads to sudden release of waters, and it poses a great threat to the human life and environment which are likely to be affected by this release of water, which is primarily the people who are living along the river channel downstream of the dam. There have been failures of the dam. Like about 200 dams failures have been noted by ICOLD, and they came out with a very important publication called Lessons Learned from Dam Failures. And then onwards there have been compilation in various countries about their own dam failures, where they occurred and how they occurred, and a lot of analysis of failures is also done in order to see that what were the causative factors which caused those failures and how those failures could be avoided. India has about 36 failures reported so far, and most common cause in India is breaching of embankment due to floods. But this is not the only cause. There are many other causes also. Many times the failures have actually pointed us to some phenomena which we were not hitherto knowing. For example, uplift was really not known when we started building the dams in early 17th and 18th centuries. At that point of time, it was considered that no water can actually penetrate a very solid masonry or a concrete wall. But then gradually it was realized that there is an uplift, and uplift can also cause a failure. And these kind of failures were noticed. Based on that, the uplift criteria came into picture. Similarly, liquefaction as a phenomena was understood well when we looked at the San Fernando dam failures, and so on and so forth. Many other issues are found out of the dam failures. And even if dam does not fail, if it goes under severe distress, then also it is capable of providing us lessons for even other dams and for the dam itself about the material behavior. So dam failures are not merely the failures, but they are lessons. And in many cases, it has been seen that failure is something which is taken as some kind of a lack of diligence, or sometimes it is taken as some kind of crime. And there is always a tendency in the dam managers to hide those failures by painting over some things, by hiding a few things. But really speaking, dam failures should not be really hidden. Dam failures should be brought out. It doesn't really mean that every time a dam failure occurs, you need to really punish people. Punishment is the greatest deterrence against the information flow. And because of that, the fear of punishment stops the information. We do not really end up learning about the causative factors, and it does not allow us to advance our science in a very critical direction. So dam failures are something which have to be taken in stride by a dam safety manager, and a dispassionate analysis without really rancor or without any other hidden agenda should be carried out in a scientific manner in order to see that these dams are capable of what were the factors that these dams actually created and how this dam failed, and then what we can learn out of these failures. These are some of the pictures of aftermath of dam failures. As you can see, Machu 2 has been a very recent disaster in 1979 in Gujarat, which wiped out one whole town of Morbi, and you can see the people were dying. The entire houses were raised as if though a storm has passed, and the carcasses of the human beings and the carcasses of animals were hanging from the electricity poles because they were not able to save themselves under the very rapidly rising water. Similarly, the loss of dam due to earthquake or due to excessive flooding creates a major disruption. It leads to the loss of reservoir, and it leads to the loss of benefits for a considerable period of time, because having failed once, you have to really think a lot, you have to work out a lot in order to restore that dam, and then there is a lot of public questions to really answer. So the aftermath of dam failure is a very difficult period in which the entire machinery of the owners and the government have to work together along with the scientific community to come to the solutions and to the measures. Now, what are the factors that affect the dam safety? One which we said earlier was the practically infinite lifespan and our understanding of the nature. Our understanding of the nature is based on the history. We have been observing this earth since long periods of time, and based on those observations, we are forming certain opinions. We are forming certain risk levels, and then those risk levels we are applying to our structures so that those structures are able to withstand those risk levels. But then we are merely a moment in the geological history of this earth, whereas the dams have to span a considerable span of the geological time of our earth. So dams face a very large variety of these situations. New situations keep on coming. For example, in case of floods, when we started out in 18th century, our instrumental observations of rainfall and our observations of discharges in the rivers were at a very limited level, and based on that some formulae were developed, some decisions were made, and based on that our design criteria kept coming up, and we built the dams. Then we realized that these are not adequate, so we changed those criteria. Now once we change the criteria, then the dam which was built previously with the previous criteria also have to be examined, that whether it is now meeting the current criteria, because you want the acceptable level of hazard. So for that you have to revise the floods. Similar is the case with the earthquakes. Our knowledge of earthquakes is limited. We need to really look at those earthquakes in a manner which is spanning over the geological periods of time, and then when new phenomena comes up, then we have to look at those phenomena and then come up with the idea of change the risk profile and then maintain the hazard level at the same place with the changed risk profile. That is where the rehabilitation or retrofitting comes in. So the factors that affect the dam safety are primarily, one is the natural phenomena. The next one is the constituent materials. The constituent materials are all man-made materials. We make those materials and we think that these materials will last forever. Now, whatever you manufacture, it always has some issues over long periods of time, and those issues have to be addressed in order to see that the material is able to maintain its strength, maintain its integrity, maintain its compactness, and come up with same level of resistance to the same level of forces, or sometimes even increased level of forces, to maintain the dam in a safe manner. Another issue important is that of the construction quality. The construction quality is very important in making a safe dam. You may employ the best of the materials, but if you do not apply those materials in a consistent manner, in a scientific manner, we may come up with a poor structure. And then poor structures will then not be durable because there will be inherent defects in them. So construction quality, even though it looks as if though this is the area of a construction engineer, but a person associated with this dam safety also has a role to play in looking at the quality that has been put in the dam while it was being constructed. Post-construction developments also affect the dam safety. Many times the flood hazard remains the same, but downstream encroachments create a problem, and because of that it becomes very difficult for the dam to release certain waters, and that may pose some extra burden or extra loads on the dam. That may pose some extra unknown kind of factors on the dam which will affect the dam safety. So we need to really look at how the downstream developments are taking place, and those post construction developments, are they impacting the dam safety, and if they are doing so, what is it that can be done for changing them.